Alright, so we're going to continue in this video with a few more examples of finding quartiles and determining the interquartile range. First, though, we're going to talk about the 5-number summary. So we have, now that we know how to calculate the quartiles and the interquartile range, we have enough tools to give a good numerical description of the data. And this is what's called the 5-number summary. As I said before, it's the min, the first quartile, the median, the third quartile, and the max. So this gives you a measure of center. Of course, that's the median. Actually, two measures of spread because we know the interquartile range, right? The distance from Q1 to Q3. And it also tells you the range because we know the distance from the min to the max. And then we also can get an idea about the skewness of the distribution by looking at how far the quartiles are from the median or the max and the min are from the median. Okay, now generally this is used for skewed distributions or ones with outliers. If we have a symmetric distribution, this really, the 5-number summary is really overkill. Instead, we're going to use the mean and the standard deviation. So that's what we're going to use for symmetric distributions. And again, for skewed or distributions with outliers, we're going to use the 5-number summary as our numerical summary of our data. All right, so we have another example here. Here we have information on the number of deaths from tornadoes in the United States from 1990 to the year 2000. Now, our data has one problem with it right now, and that is that it has not been put into order. And we need to do that if we're going to find these statistics by hand. Of course, if you're putting it into software, you don't need to put it in order, but you're also not going to get out exactly the right value for the quartiles. So I'm going to mark these off as we go. We've got 25, 30, 33, 239s. And then what do we got? 40 next, 53, 67, 69, 94, and 130. And so now that we've put these in order, we're looking at that 130 and we're saying, is that an outlier or not? Okay, so first we look at this and we say, okay, we have a sample size of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. So first we want to find our median, of course. And so we're in place number n plus 1 over 2, which is of course 6. So that tells us that our median is that 40 data value, right? Okay, so now we're going to say, okay, we're going to divide our data into the lower half and the upper half. And remember, we are not going to include the median in either half. Since it's an actual data value this time, we got to make sure that we don't do that. There are some methods that do include the median, and it's a perfectly acceptable way of doing things, but on the homework, it's not going to get counted as correct if you include the median in the middle, just because the computer's kind of stupid about these things, right? But so I want you on tests and whatnot to do it this way. All right, so now we're going to look, I'm going to label our place values here for the first part. So we're looking at this bottom half of the data. We want to find our quartiles, our Q1. Of course, we have 5 data values in the bottom half, and so we know we're going to be in place number 5 plus 1 over 2, which is 3. And so we're looking at our first quartile being 33. So Q1 equals 33. And then we're going to do the same thing for Q3. We're going to say, okay, we've got 5 data values in the upper half. And so again, we're in position 6 over 2, or 3. And so we count 1, 2, 3, 4, 5. So we're in position 3, so that means our Q3, our third quartile, is 69 in this case. All right, so what that's saying is that 33, the value 33 has 25% of the data at or below it, and the value 69 has 75% of the data at or below it. Now, of course, it's easy to figure out our interquartile range. This is just going to be Q3 minus Q1, which is 69 minus 33, otherwise known as 36. All right, so what happens if we have a typo here? Let's pretend that someone was inputting these data values and instead of 130, they input 1300. So what happens, right? What happens to all of our statistics? Of course, when this happens, what's going to happen to our median? Well, now the sum of all our data values has gone up significantly, so our, sorry, I'm thinking the mean. I meant to say mean. Our mean is going to increase, right? Because our sum of all our data values has increased. Our standard deviation, likewise, the mean's gone up a little bit, yes, but definitely that outlier is increasing the average distance of all the points from the mean. So it's going to have increased as well. What about our median? Well, even with that 1300 there, that middle number in the data set is still 40, so we have no change for our median. Same thing for Q1. No change, the bottom 25% is still the same. And our Q3 also, no change. And of course, since the quartiles are not changing, the interquartile range also no change, right? Because the interquartile range and the quartiles, they only care about position. They don't care about value of the data values. So the interquartile range is going to be the middle 50% of the data. It cares about values in the sense that that's going to give us a measure of the spread, but if those middle values don't change, interquartile range is not changing. All right, so let's look at our 5-number summary here. Sorry. So our 5-number summary, let's see, we had 25, 33, 40, 69. So 25, 33, 40, 69, and going back to the original data, 130. So looking at our distribution here, it might actually be easier to interpret as a graph. But for right now, we can look at this and say, okay, there's a distance of 7 in between our median and our Q1. And there's a distance of 29 in between our median and our Q3. So that part of the data is much more spread out from the 50th to the 75th percentile than it is from the 25th to the 50th percentile. Similarly, our bottom 25% of the data goes from 25 to 33, so that's only 8. Whereas at the top half of the data, the top fourth of the data, sorry, we're looking at a distance of 61. So from this tells us that this 130 is either an outlier or that our distribution is skewed right. And it may in fact be both, because our distance from the median to the Q3 is also more spread out than from Q1 to the median. So box plots are going to show our 5-number summary graphically. That's going to be in the next video lesson. Okay, so we have one last example here. We've got the costs of 10 electric smooth top ranges that were rated very good or excellent by Consumer Reports. I've already put the data in order here, and we have, let's see, it looks like 10 data values. So our sample size is 10. So we want to find the median and the quartiles in the interquartile range here. So of course our median, we're looking at n plus 1 over 2 for our place value. So we're looking at place number 5.5, right? Which means, let's see here, 1, 2, 3, 4, 5, 6, which means that we are averaging between the 5th and 6th data values, which means that we're looking halfway between 900 and 1,000, which is 950. So our median is equal to 950. Then we want to find our quartiles. So what about for Q1? We're looking at our bottom half of the data. Now here again, we don't have a median that's actually a data value, so I'm just going to cut it in half in between the 5th and the 6th data values, and we're going to look at the bottom 5 data values. So we're looking at position 5 plus 1 over 2, which is position 3. And so that means that our Q1 is 850 because it's in position 3. And then we can do the same thing with Q3, right? We're looking at, so here's our Q1. So we're looking at our top half of the data, these 5 numbers, and of course our Q3 is going to be that number physically in the middle, right? 1050. All right, so we could renumber these 1, 2, 3, 4, 5, and again we're going to be in position 3. All right, so our interquartile range, what is it going to be? Interquartile range is equal to, remember, Q3 minus Q1. So this is going to be 1050 minus 850, which is an interquartile range of 200. So that means that the middle 50% of our data, the middle 5-ish numbers really, goes from 850 to 1050, a distance or spread of 200. And so one last thing, what's the 5-number summary for this distribution? Of course, it's the min, right? Q1, our median, oops, 950, I left a number out, our Q3, and our max. And that's it for this lesson. Thank you.